Hello and welcome back. This is presentation 7.7. The topic is inferences regarding proportions. This material is in your workbook, pages 715 onwards, and your textbook, chapter 7. To illustrate the concepts involved, we're going to consider a large population of birds infected with a particular strain of bird flu. The infection rate is around 20%, and we're going to suggest that the binomial random variable model applies here, and you should review those. Under repeated samplings of size 64, so we're taking samples of size 64 birds and finding the number of animals with that flu, and we come up with these proportions, and you'll notice that they'll cluster around the 20%, and you can see over here there's 4 of them coming on the screen now. And we're saying that standard error given here, and we see it over here, is 0.005. Here's the formula for it. And this gives rise to a 68% confidence interval, if you wish. This is called your standard error, and that's used to measure the other variables involved. Now, coming on the screen now is the concept of the standard error, and we're saying the 0.05 is your standard error. If we look at a 95% confidence interval, the z-score is plus or minus 1.96. If we take that 1.96 multiplied by your standard error, we get your 95% margin of error, and that's given on the screen here, 0.098. Now coming down here, if we take repeated samplings, we're saying that the proportions should cluster around 20, and you see them coming on the screen here now. And there's 20 of them there, and if we lay off the margin of error on each of them, we have 20 intervals, 19 of which will capture the true proportion p. On average, 1 in 20 won't. And therefore, we have the concept of a 95% confidence interval. So if we take any one of them, p hat 0.247, and add and subtract your margin of error, we get the notion of the true proportion being 14.9% to 34.5%. Now on the screen here we see the hypothetical experiment clinical trials involving treatment of flu with a device called Tamiflu, and we take 724 flu patients and were treated, and 72 experienced nausea or an adverse reaction. To find a confidence limit for that true population proportion, and we see them coming on the screen here. An estimate of p hat is that 72 over 724, so we're saying that the true proportion is something around 9.95%. The standard error, now here we use the p hat as an estimate of the true p. We've got it in here. This is your standard error, and that's your 60% region here. And coming down here, we find that that is your standard error. Now looking at the confidence limits, for 95% confidence, z is plus or minus 1.96, and your margin of error coming on the screen here now is 0.0218. and that is the 95% confidence notion here. Coming down here then, we're saying if we're given one sample proportion of 0.0995, which we got from our estimate up here, using that plus or minus 0.0218, we have the confidence interval coming on the screen here between 7.8 and 12.1%. 95% of the time, these intervals will capture the true population proportion. If the rate of nausea amongst patients given placebo is 6%, what does this say? This constitutes sufficient evidence to say the rate of nausea is significantly above normal. And that's the end of this presentation 7.7. We ask that you review it once again and then go on to 7.8.